Before we get started, are there questions over the homework? There's a homework on our previous assignments about our inverse variation and direct variation. Inverse variation, direct variation, not too bad so far. And unfortunately, that's about all we're going to talk about with direct and inverse variation. Now, the main reason that we brought it up with this here is that inverse variation is a fraction. That's really the main reason we brought it up, was the fact that inverse variation is a over x. So we're talking about fraction, a rational expression, which is this entire chapter. So for the most part, it does fit, but it doesn't mean it fits in nicely with the chapter. So what we're going to be talking about today, and really today's the first real day we're going to dig into rational expressions. Now, with rational expressions, we can say a rational expression is in simplest form when its numerator and denominator have no common factors other than positive or negative 1. There is nothing in common on top and bottom that can be simplified or reduced out. Now, there is one thing we do have to be careful with, is in top or bottom of a fraction. When we have two terms being added or subtracted, we need to treat them as a single term, a single expression. So even though we do have 2 on top and bottom, because of that plus, the x plus 2 is stuck together. It's one expression, it's one part of the term. We can't just cross out the 2 on top and bottom because the 2 on top is stuck with that x plus 2 is a single expression. Now if we had 2 times the quantity x plus 2, that 2 out front and that 2 on bottom, we can reduce those. There's really what we can say that this is. It says 2 over 2 times our x plus 2 over 1. Because a multiplication, we can split it, we can combine it. Because if we multiply these two back together, the 2 would multiply with the x plus 2 on top. The 2 on bottom would multiply with our 1. But here 2 divided by 2 is 1. It simplifies. Or for the most part, we'll cross this out and say that we just have x plus 2 over 1. We do this simplifying down. If there's anything in common on top and bottom, it needs to reduce. So let a, b, and c be expressions with a and b different than 0, because we can't have a division of 0. If we do have something in common on top and bottom, we divide it out, we simplify it out. And we have this expression or example here, 15 over 65. There's a greatest common factor of 5 on top and bottom. It can reduce out. Same with our second one. It has a common factor of x plus 3 on top and bottom. It reduces out. So if there is something in common on top and bottom, we have to reduce it. We have to simplify it out. So the first thing we're looking at is simplifying these rational expressions as far as possible. So when we look at this first one here, we have 4 over x times the quantity x plus 2. What's in common on top and bottom? Nothing. There's nothing in common, yes? That's simplified. And this is already simplified. There's nothing we can do to it because there is nothing in common on top and bottom. It is already reduced. Now we will talk a little bit about this here, but also we do have restrictions with these rational expressions, because with polynomials, what we did for most of the fall had no restrictions, but rational expressions have restrictions because the bottom of the fraction cannot be 0. Because really, if the denominator is 0, we're really dividing by 0. We cannot divide by 0. So we do talk about restrictions. And the restrictions are whatever is going to make the bottom of this fraction be 0. And there's two places here that it can be 0. One is with the x, and the other is with the x plus 2. And whatever value is going to make both of these be 0, or either one of these be 0, we can't have. If we're solving or using this, it can't be 0. Well, the one on the left is just telling us x cannot be 0, because if x is 0, we have a denominator of 0. Division of 0, it doesn't work. X plus 2. This one here we have to do a little more. We have to solve for x. We can subtract 2 from both sides, telling us x cannot be what? So if x is 0 or negative 2, we have a division of 0. It doesn't work. And this will really come more into play, especially when we start solving, because if I solve the equation, solve this rational equation, and get a value of 0 or negative 2 for this here, it doesn't work. It's an extraneous solution. We have to throw it out. We cannot have division of 0. We can't divide by 0. All right. Let's look at this one here. So we have 2 times x plus 1 over x plus 1 times x plus 3. What's in common on top and bottom? X plus 1. So the x plus 1 on top and bottom would reduce, leaving us what on top? 2. What on bottom? X plus 3, because our x plus 1 and x plus 1 simplify out, leaving us with 2 over x plus 3. Because really what is happening here is that we can say that we're splitting it up into a multiplication. We're splitting the top apart. We're leaving the 2 and moving the x plus 1 over. On bottom, we'll leave the x plus 3, move this over here. And this is purely with multiplication. We can do this with multiplication. We can't do it if it's just being added. Because what is x plus 1 divided by x plus 1? Anything divided by itself is 1. So this whole term reduces to 1. So we're saying 2 over x plus 3 times 1 is just 2 over x plus 3. Questions on how we got to that there? Our restrictions are what x cannot be. And again, there was 2 things that started off in the bottom of the fraction. The x plus 1, x plus 3. And again, neither one of these can be 0. Whatever's in the bottom of the fraction cannot be 0. Yes. Because if we look at this here, here we would subtract 1 from both sides, telling us that negative 1 would cause our x plus 1 to be 0. So x cannot be negative 1. For x plus 3, we can subtract 3 from both sides, telling us x, if x is negative 3, the x plus 3 would be 0. So x cannot be negative 3. So if x is a value of negative 1 or negative 3, it would cause a division of 0. It doesn't work. Now, depending on the textbook or depending on the instructor, some would say that we need to list, if we wanted the restrictions that ask for the restrictions, we need to list both negative 1 and negative 3. Some do not say we need to list both. Some books say we just need to list the fact that x cannot be negative 1. And the reason they only want this is because in our final expression, the x plus 1, that restriction, simplified out. They only want to list the restrictions that are been removed, or the ones that have been removed from the equation, the expression. Those are the only ones we have to list because, well, the negative 3 is still there. The x plus 3, we can still see that negative 3 would cause a division of 0. But because the x plus 1 was removed, we need to show that it's still a restriction. Can't be -1. Because again, when we refer back to it or talking back to it, we're more referring back to the starting problem, not so much our final result. I think it's better to just list them both than it is to try to figure out which ones we need to, which ones we don't. Let's just list them all. Because there's nothing wrong with listing the fact that x is not equal to -3, even though it's still there. Does that kind of make sense? More cutting hairs than anything else. So we kind of get this idea of simplifying out what's in common on top and bottom. Now, not every expression is going to be factored like the previous one. There are some we're going to have to factor ourselves. And again, this is why we went back over factoring before starting this chapter, just to refresh ourselves. So this here, we have one expression, we have the numerator, and we have the denominator. The way we go about factoring this and choosing which one we factor first doesn't really matter. We just have to factor one, then factor the other. I would always start with factoring the one I can see the factors for first. The x squared minus 4 on bottom is the difference of perfect squares, yes? Which is indeed yes. Our x plus 2 and x minus 2. Because this is just going back to our a squared minus b squared is a plus b times a minus b. Always start with the one that we can see the factors of first. Or ones that we know don't factor at all. Because then we just rewrite them. Questions on this so far? Now there's a reason behind this, and it's because it's going to help us. Now if we look at the numerator, x squared minus 4x minus 12, there is no greatest common factor. Quadratic, so we'll have our two sets of parentheses with 3 spaces, yes? Third term is negative, so the signs are opposite, plus and minus. Factors of the first term, x and x. Factors of the third term, factors of 12. 2, 6. 2 and 6. X plus 2, x minus 6. Now, so we'll do positive 2, negative 6, and if we check this here, x times negative 6 will be negative 6x. 2 times x is plus 2x, giving us negative 4x, the middle term we wanted. Now, some of the reasons I say factor the one we can see the factors of first is going to be nice, is because we knew the denominator was x plus 2 and x minus 2, yes? If something's going to simplify, the numerator of this had to have either what? An x plus 2 or x minus 2. Because if it had one of those two factors, it's going to simplify on top and bottom. If it doesn't, there's going to be no simplification. There's nothing we can simplify. So what that means for us is, especially when I'm looking at the factors of 12, if the factors of the third term were 1 and 12 or 3 and 4, would anything have simplified? Well, with 3 and 4, we would either had x plus 3 and x minus 4, or x minus 4, x plus 3. Nothing in common on top and bottom. Same with 1 and 12. So since we got the x plus 2, x minus 2 first, it gave us a hint that one of the two sets of parentheses in the numerator had to either be x plus 2 or x minus 2 for something to simplify. It gave me a hint at what the factors of the top needed to be for something to simplify. It gives me a way to kind of get through some of the check process. This here did work. Now what's in common on top and bottom? X plus 2 and x plus 2. Leaving us with x minus 6 over x minus 2. Questions on this here? Two things we have in the bottom of the fraction. X plus 2, solve for it. So it would be 0 when x is negative 2, so it can't be that. For x minus 2, when we solve it, x cannot be 2. So our restrictions here is that x cannot be negative 2 or 2. Now, yes, we could write this a little bit easier. We could say that x is not equal to positive or negative 2. And even on the last one, we can. All right, guys, focus up here. We could write it as a single statement. It's just we put commas. So on the last one here, we could have said that x is not equal to negative 1 or negative 3. Same thing with listing solutions. X is equal to negative 1, comma, negative 3, comma, 4. We can list them out instead of writing x equals or x is not equal to multiple times. Questions on how we did this here? Questions on any of this so far? We ready for the next one? X squared minus x minus 12 over x squared minus 9. So we need to figure out which one we want to factor first. If we can do the top or bottom, I like the x squared minus 9 because it is a what? Difference of perfect squares. X plus 3 and x minus 3. Because x squared minus 9 is our difference of perfect squares. X times x is our x squared. 3 times 3 is 9. So we have x plus 3, x minus 3. Which means one of the parentheses on top is either going to be x plus 3 or x minus 3. It has to be one or the other. Now we factor the numerator. Again, always look for greatest common factor, something that will divide into all three terms, something in common in all three terms, or two terms. Since the 12 is negative, our signs are opposite. Factors of x squared are x and x. Factors of 12. 3 and 4. Which one's positive, which one's negative? 3 and 4. Again, it's still going to be good to check and make sure we do get the correct middle term. X times negative 4 is indeed negative 4x. 3 times x is going to be plus 3x, giving us negative x, which is what we wanted. Now what's in common on top and bottom? X plus 3, x plus 3. Leaving us with minus 4 over yes, x cannot equal negative 3 or 3 because our two spots where we can have a division of 0 is with our x plus 3 and x minus 3. With x plus 3, we would subtract 3 from both sides, telling us that if x is equal to negative 3, we'd have a division of 0. It does not work. X minus 3, we can solve for x by adding 3 to both sides, which tells us that if x is equal to 3, again, we'd have a division of 0. It doesn't work. So our restrictions for this here are negative 3 and 3. Questions on this so far? We're ready for the next one. X plus 4 over x squared minus 16. The numerator, x plus 4. Can it factor? What's the degree on top? So not quite. So the degree of the numerator, so the degree of x plus 4, what is the biggest exponent attached to the variable with x plus 4? 1, because we'd only have x, so the degree is 1. Because once we get the degree down to 1, that's a key indicator it's not going to factor. X plus 4 is as simplified as it gets. The only other way to factor these two terms for x plus 4 is if there's a greatest common factor. There's a number that goes into x and 4, which there is not. So we can keep it as just x plus 4. Now the x squared minus 16, there's not a greatest common factor between x squared and 16. But it is a difference of perfect squares. It would indeed be x plus 4 and x minus 4. Now x plus 4 and x plus 4 are in common. Now the bottom of the fraction, we have x minus 4 left. What would the numerator be? Because whenever we're factoring out, we're simplifying this down, it will never simplify to 0. It will only simplify to 1. Because x plus 4 over x plus 4 is x. Anything divided by itself is 1. So the numerator reduces to 1. And that's as far as we can go, because there are no other common factors. So this just reduces to 1 over x minus 4. Yes. Our two places that we can get 0 are x plus 4 and x minus 4. So to find the restrictions, we'd set both of these equal to 0 and solve. First one, we would subtract 4 from both sides, telling us x cannot be negative 4. For the second one, we'd add 4, telling us that x cannot be 4. So if x is 4 or negative 4, we'd have a division of 0. They do not work. Questions on this here? Questions on anything we've done so far? We're good with this here. X squared minus 2x minus 3 over x squared minus x minus 6. As tempting as it is to cross the x squareds out, we can't. Because again, those minuses and pluses make that one term. They are all stuck together. We can't just cross these out. That unfortunately doesn't work. It'd be nice if it did, but unfortunately the x squared minus 2x minus 3 is one expression. It's one term. We can't just break it up like we can with multiplication. Multiplication, we can split them apart easily. Addition, subtraction is a little bit harder. So the first thing we're going to have to do is factor. So the top and bottom, we'll start with the top. 2x squared minus 2x minus 3. There is no greatest common factor between these three terms. Since the third term is negative, our signs are opposite. Factors of x squared would indeed be x and x, and factors of 3. 1 and 3. And we can check our middle term. X times negative 3 is negative 3x. 1 times x is going to be plus x. And negative 3x plus x is going to give us our negative 2x. So that is the correct set of factors. Yes. Yes. So no greatest common factor, nothing that will go into all three terms. Third term is negative also, so our signs are indeed opposite. Only factors of x squared. Questions on this so far? So if we check the middle term, x times negative 3 would indeed be negative 3x. 2 times x is plus 2x, giving us the negative x that we wanted. All right, guys. All right, guys. Let's focus on. So x minus 3 is common on top and bottom, so it will factor out, leaving us with x plus 1 over x plus 2. Now we can't just cross out the x and x, because again, they're stuck together. X plus 1 is one expression, x plus 2 is an expression. We have to keep them together. So that is as simplified as it gets. X. If x is negative 2, we get a division of 0. Here we'd add 3. Telling us that if x is equal to 3, we'd get a division of 0. So for this one here, x cannot be negative 2 or 3. Questions on this here? So again, most of this, especially with our expressions, really revolves around factoring. Factoring the top, factoring the bottom, and simplifying from there. And here, when we factored the numerator and got the x plus 1, x minus 3, it gave us a big hint at what the bottom is going to be. Because either we're using 1 and 6 or 2 and 3. If we had used 1 and 6, the 1 would have to be positive to match up with the x plus 1. Since we used 2 and 3, the 3 had to be negative to match up with our x minus 3. Otherwise, we wouldn't have anything in common. Questions on anything we've done so far before we look at multiplication? When multiplying two rational expressions, we multiply numerators with numerators, denominators with denominators, and then simplify if there's anything in common. We simplify anything that's in common on top and bottom when it's possible. Now there's different ways we can do this. There's two really main ways we can do this. The first is that we multiply everything and then simplify. So we look at the numerator and we multiply this together because we're multiplying numerator with numerator, the top of the fraction with the top of the fraction. We're going to multiply numbers first. 8 times 7 is 56. Then we're going to multiply our x to the third times x to the fourth. Yes, when we multiply like bases, we add the exponents. Since we had 3 in one, 4 in the other, our 3 plus 4 would give us 7. And our y times y to the third, even though it's not written, it is y to the first. So we have 1 plus 3, giving us 4. And lastly, on bottom, we'll do the same thing. 2 times 4 is 8. X, there is no other x, so yes, indeed, it would be x. And our y squared times y would be y to the third. Questions on how we multiply these two here? Because we've done some of this before. Y'all have done this before in Algebra 2 or Algebra 1. Multiplying like fractions as we multiply top with top, bottom with bottom. Now we just need to simplify. Now the nice one out of these two is the 56 over 8. Yes. And 56 over 8 would reduce to 7. Would it be on top or bottom of the fraction? Top or bottom? Because we really have 7 over 1. It's reduced evenly. Yes. Because 8 divided by 8 would be 1. 56 divided by 8 is 7. We're removing that 8 from both terms. Now the next one we have is our variable, x to the 7 over x. Now when we multiply like bases, we add the exponents. When we divide like bases, we would subtract. So even though it's not written, the exponent on bottom is 1. So we're doing 7 minus 1 is it bigger on top or bottom? If it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. So x to the 6 is on top. That brings us with y to the 4th over y to the 3rd. Dividing like bases, we subtract the exponents. So 4 minus 3 is just 1. So y, bigger on top or bottom? Top. So it stays on top. Now since nothing was left in the bottom of the fraction is just 1. So 7 x to the 6 y is the final answer. X and y did show up in the bottom of the fraction. And they're being multiplied together. And neither one of these can be 0. Really, x can't be 0, y can't be 0. Because they're all being multiplied together. Because if we plug, so 8xy cubed is really, is where we have in the denominator. Now, if x is 0, no matter what y is, 8 times 0 is 0, times y to the 3rd is still just 0. If we plug 0 in for y to the 3rd, again, we get that same result. Since we only have one expression and everything's being multiplied together, x and y cannot be 0. Questions on this here? Yes. Six x squared y over 3xy cubed times 9x to the 5th y squared over 2y. Well, actually, before we move on, I'm going to look back at this here because, again, we said we can do this in more than one way. And, again, that is true. I'm going to erase this here. I want to look at this first rational expression first. We have 8x cubed y over 2xy squared, yes? Well, 8 over 2 reduced. Well, yes. Because 8 over 2 is going to be 4 over 1, yes? There's nothing that said we had to multiply before we reduce. Because in the first expression, we do have like terms on top and bottom. We can reduce it to begin with. X to the 3rd over x to the 1st. When we divide like bases, we subtract the exponents. So 3 minus 1 is 2. And since it's bigger on top, it stays on top.
So if it was bigger on bottom, should we fix the bottom?
Yeah, so let's look at y. We have y over y squared. Exponent on top is 1. Bottom is 2. So 2 minus 1 is it bigger on top or bottom? So it stays on bottom. 7 over 4 in our next expression. Well, 7 over 4 has nothing in common on top and bottom. So it just stays 7 over 4. X to the fourth. On top, there is no x variable on bottom. So there's nothing to reduce it with. Y to the third over y. Well, that'd be 3 minus 1, which is 2. And since it's bigger on top, it stays on top. Now we can do the exact same process we just did. 4 times 7 is 28. X squared times x to the fourth. 2 plus 4 is 6. Y squared. On bottom we have 4 times y, which is 4y. 28 over 4 is going to reduce to 7 over 1. There is no x variable in common on top and bottom. So we're left with x to the 6th. Y squared over y. 2 minus 1 is 2. 2 minus 1 is 1. And it's bigger on top, so it stays on top. So we do get to the same answer. So there are more than one ways to do this, because again, we're just simplifying with our multiplication. Questions on any of this here? We'll stop there. We'll pick this up tomorrow.